Let's provide a solution to this question. Solid mechanics. A mass concrete pair of rectangle cross-section 600 millimeter and 800 millimeter, 2.2 meter carried an axial compressive load of 2.5 megawatts. Determine the following. The question says we are to determine the stress in the concrete at the base of the pair. And the second question says that the amount of shooting that will occur in pair, and the density of the concrete pair was 2,200 kg per meter cube, and our Young modulus is 13 kilonewton millimeter square. So how can we find the solution of this problem? Let's figure out our data. Let's have the solution of this question and figure out our data. From our data, we are having the cross section of pair, which was the cross section from the question. Our cross section is 600 millimeter and 800 millimeter. 600 millimeter by 800 millimeter. If we say 600 multiplied by 800, we're having 480,000 millimeter. So the second data is height of the pair, which was 2.2 meter. The height of pair. So our height of pair is 2.2 meter, but we are to convert it to millimeter. So we'll end up having 2,000. So we're having 2,200 millimeter. So the next data we have for the axial compressive load. This is our axial compressive load. The axial compressive load. Our axial compressive load is 2.5 megawatts. 2.5 times 10 exponential of 6 watts. So therefore the 2.5 megawatts, this is the value of it, the axial compressive load. And then question, so we are to determine the stress in the concrete at the base of the pair and the amount of the shortening. So the next data we have to figure out the density of concrete. The density of concrete is given as density of concrete 2,200 kilojoule per meter cube, and therefore our Young modulus. The Young modulus is 13 kilonewton millimeter square. So let's first calculate the first question that say that determine the following stress in the concrete. So what formula can we use? We have to use the stress, which we can donate it as sigma, which is equals to load over area. So therefore the stress let me say sigma, it is equals to the load over the area. So therefore, what is the value of the load? Value of the load is what we are having. The force load is like the force, and the stress is equals to force per unit area, and we have to say 2.6 times 10 exponential of 6. Sigma is equals to 2.5 times 10 exponential of 6 watts over the area. The value of area is 480,000. So what is the value of this sigma, the stress? 2.5 times 10 exponential of 6 divided by 480,000 will end up having 5.208 5.208. So this is the value. Let's insert our unit. Newton per millimeter square. So this is the final solution for the first question. Let's determine the shortening of pair. Okay. The second question. Let's insert our data. We are to find the shortening, which is the change of L. So therefore, the change of L is P multiplied by L over A, area multiplied by the Young modulus. So what is the value of P? The value of P is 2.5 times 10 exponential of 6 Newton. So what's the value of L? The value of L is 2200, and therefore the value of the Young modulus, our Young modulus is 13 times 10 exponential of 3 Newton millimeter square. Here we're having millimeter. So the next thing is the area. We all know our area. Area is 480,000 millimeter. So let's insert the value and find our solution for the problem. So let's substitute the change in L, which was the shortening. Our value of P is 2.5 times 10 exponential of 6 multiplied by the 2,200 all over the area, which was 480,000 multiplied by the Young modulus, 13 times 10 exponential of 3. The reason why we say 13 times exponential of 3 because we're having kilo, and kilo is the same thing as 1,000. Okay, let's solve the calculation. 2.5 times 10 exponential of 6 will end up having 0.881. Solution to the second question that say that find the amount of the shortening that will occur in pair and given the density. So this is the solution of this video. I hope the video is more helpful to you in solving different kind of questions on solid mechanics.